Today we are going to discuss inequalities. So let's move this blank piece. So inequalities signs look like this. You have greater than, you have greater than or equal to, you have less than, you have less than or equal to, and those are the ones that we're going to work on, but you also have not equal to, but we're not going to use that. That's an inequality, so not equal to. So this is greater than or equal to. This is less than, and this is less than or equal to. And this looks like the letter L. If you look at this less than sign, kind of looks like a lazy L. So that's how I always remember that one is less than and the other one is the greater than. Now, when we graph them, greater than, we're going to have an open circle because we don't include it. And we'll go into this a little bit more detail. That is a closed circle because it's equal to, meaning we include the border. This is less than is open circle, and greater than or equal to is going to be a closed circle. And you'll understand that a little bit better when we do this first example. So when we see P is less than or equal to 5, so we know that P is equal to the solutions. So when we see P is less than or equal to 5, we know that the solutions are going to be less than 5 and equal to 5. So where on this graph? This is sort of that border right here between the solutions and the non-solutions. So if I plug in a 5 for P, is that less than or equal to it? Yeah, it's equal to it. So 5 is a solution. Is 6 less than 5? No, so 6 is not a solution. How about 4? Is 4 less than 5? Yeah, it's less than. So all these values are going to be that way. And we have a closed circle here because we want to include the number 5. We want 5 to be included, so that's why we have a closed circle over the border. We call that the border between the true values and the false values. So, and we know that this is the solutions are less than 5. So that's why I knew I was going to go to the left, because values will be less and greater. So we just want the values that are less than 5. When we have P is less than 4, we have to think about it in a little bit different way. If we plug 4 in, that's that border, is 4 less than 4? No. 4 is equal to 4. So we can't include 4. 4 is not a solution. Well, is 3 less than 4? Yes, so 3 is a solution. 2 is a solution, all those. What about 3.5? Is 3.5 less than 4? Uh-huh. How about 3.9? Yes. How about 3.99? Yes. 3.9999? Yes. So we need to get infinitely close to 4 without including 4. So the way that we describe that is we put an open circle. And so we want all the values less than 4, but infinitely close to 4 without including it. So the way we notate that is an open circle over the 4 tells us that we want to get as close to 4, but we can't include 4 because 4 is not less than that value. The next one is an interesting one. And what do we notice about this problem? Hopefully what you notice is that the variable comes second. So my advice to you is that you rewrite it with the variable first. Now we have to be observant here. We notice that right now this inequality is eating the 3. So when I reverse it, when I put the variable first, that inequality should still be eating the 3. Okay, so, and we need the equal sign because there was an equal sign. So we went from 3 is greater than or equal to k is less than or equal to 3. Those are equivalent inequality statements. So now we know our solutions are less than or equal to 3. So since there's an equal sign, we're going to include it. So that means it's a closed circle. Since our solutions are less than 3, we're going to go to the left. Here we go again. We have 2 is greater than or equal to r. Let's rewrite it with the variable coming first. The inequality is eating the 2, meaning instead of eating the r, that would be eating the variable. So now we have our solutions are less than or equal to 2. We're going to have a closed circle, again going to the left. Now let's take a, oh, that's unfortunate. I didn't mean for that to be both of those. We don't need to see that. There we go. Let's try those two. What I'd like you to do is take a second and try graphing these two inequalities. When you're ready, hit play. You should be writing it down in your notebook so you can check against mine. Okay, so this statement says x is less than or equal to 2. We've noticed that all of these have been less than. That is not very smart of Mr. Mack on these exercises. Good, so we have a less than or equal to, so we're going to have a closed circle over 2, and we have less than, the solutions are less than 2, so we're going to draw to the left. Number 6, m is less than -1. That means our solutions are less than -1. It doesn't have an equal sign, so we're going to do an open circle going to the left because the solutions are less than. All right, the next step is now we have to solve. We have things adding and subtracting to our variable, so we have to isolate the variable first. What's happening to the variable? 16 is being subtracted. The inverse of subtracting 16 is adding 16. So we get 1 is less than or equal to n. My variable didn't come first, so I'm going to rewrite this inequality. We notice that the inequality is eating the n. So when I rewrite it, I need to make sure that it's still eating the n. And if I read this, n is greater than or equal to 1, that means my solutions are greater than or equal to 1. I go to 1, since there's an equal, I close the circle. We want to include 1 in the solutions, and it's greater than. So this is our first one going in the other direction. So those are values that are greater than 1. Take a second and try this one. Remember, show your work. Then once you have your solution, graph it, and when you're ready, hit play. So looking at this, what's happening to the variable? 14 is being added to it. Let's subtract 14 from both sides. You get -10 is less than k. Again, my variable didn't come first, so I'm going to rewrite it. And it's eating the variable, so I'm going to rewrite it with it still eating the variable. It says k is greater than or equal to -10. My solutions are greater than or equal to -10. I'm going to do a closed circle because there's an equal sign, and values that are greater go to the right. Let's try this one. This is an interesting one. This is the one that we're going to discuss. So before we do this, let's talk about this. What if I have -n plus 1 is less than 2? So my issue is I have a negative variable. Now there's two ways to make that variable positive. I can multiply by a -1 once I isolate it, or what is more interesting is what if I add n to both sides? That changes this variable from negative to positive. Notice that my variable is now a positive variable. When we had an equal sign, if it was in an equation, like that, if we added n, it didn't matter because equal signs are balanced, meaning the left side is equal to the right side. It is a balanced beam, and we're okay with that. We need to understand that with inequalities, they are not balanced, and that when we look at this, oops, sorry, didn't mean to do that, hold on. When we, still doing it, but I'll erase that. When we do this, we notice that this side is more than this side because 2 is greater than, right? It's eating the bigger one. So it's not an equal, it's actually, sorry, that wouldn't be balanced properly. It's balanced that way. That's horrible. Seesaw, sorry. The right side is greater than, it's heavier, it's more than that left side. So we have to be very clear. Ooh, look at all this stuff Mr. Mac is doing. This is just a mess right at the moment. Ay, ay, ay. So when we move things from one side to the other in an inequality, we need to understand that it's not the same. So when we had this, I forget if it was less than or greater than. So when we move this n over, that's huge. That's putting it on the other side of the balance beam. So that's important. So when we move it to the other side, you're actually changing what side is greater than. So why does that matter? Because you'll see that when you were taught in 7th grade or 6th grade, that the way that you multiply by -1, you had to remember to flip the inequality sign. Well, you need to know why you had to flip it. The reason you had to flip it is because when you move a variable, why does that keep doing that, Mr. Mac? I don't know why it's doing it. Sorry. When you move it to the other side, you're moving it to the other side of this inequality sign. So it went from less than on this side to greater than on this side. So notice we went from less than to greater than. So that's why we're flipping the inequality when we multiply by -1, because instead of physically moving it over, we just multiply by -1 and it can stay on its side. Very, very complicated. Probably not all of you are going to understand this. But with this problem, because we're only adding and subtracting, we're going to add the variable over in order to get it positive. So that would be my advice for you at this point. Let's get the variable positive, and then let's isolate for the variable. So we get n is greater than 13. Since it's greater than, it's going to be an open circle. Over 13, n is greater than, my solutions are greater than, and that's where you're going to go with that. That one's a tough one to explain without anybody being in the classroom. So what I want you to do with number 10 is pause the video. You try this one. I would advise you to get the variable positive by moving it to the other side. When you're ready, hit play. So again, I would first, because my variable is negative, I would add r to both sides. And now you get r minus 1 is less than 2. We're going to add 1 to both sides. That leaves me with r is less than or equal to 3. Since it's equal to, I'm going to have a closed circle. Values are less than. I'm going to go to the left. I like this one. This is a good one. Whenever we have double signs, we're always going to simplify those double signs prior to isolating. So a positive times a negative is going to give me a negative. And now I'm going to isolate. What gets rid of a -6 is a +6. R is greater than 19. Since there's no equal sign, we cannot include 19 in our solution, so we have an open circle, and my solutions are greater than 19, so I'm going to draw to the right. You'll notice that I'm doing my graph of my items, I'm going to group that. I'm doing it above the graph because if it's here, it's kind of hard to see your work and it gets sort of missed in there. It makes it very challenging to see if it's an open circle, if the arrow is going to the left or to the right. If I put it over the graph, then I can absolutely see. It's very clear. I see it's an open circle. I see that my solutions are going to the right. So I would advise you to do that. That's another one of those things that I would love to change mathematics across the world. You try this one. Take a moment. Show your work, graph your solution. When you're ready, hit play. So again, we have double signs. A negative and a negative makes a positive. I'm going to rewrite it instead of just having that chicken scratch above it. I'm going to subtract 2 from both sides. I get x is greater than 8. Since it's greater than, it's an open circle. Greater than goes to the right. Hope that helps. Let me know. Come and check in with me if you have any questions.